So, okay, this is quite a nice problem, and this is taken from a shortlist 2021, and this is number 31 more problem. And the question statement is find all positive integers and greater than 1 such that there exists a pair AB of positive integers such that a square plus b plus 3 is not divisible by the cube of any prime, and there is a condition n equals to a. Okay, so there is a condition, so this is the condition. So the first thing is, this is kind of problem connected with divisibility things and stuffs, and we have a nice actually criteria in this problem, and this is actually this one. So I'm going to start my work from this thing. So at first, what is this thing? So the main thing is, when we actually see a problem, a divisibility criteria related problem, where different types of, different types of variable is added, and our goal in the time is trying to simplify as much as we can. So I'm going to simplify this as much as I can. So how to simplify this? So at first, the easy way to simplify is just, okay, how I'm just going to show that how I'm just going to do that. So at first, so this is the thing, AB plus 3B plus 8. So if we want to simplify this thing, the main problem is the main variables is AB and 3B. So we are going to do is eliminating them. So how we are going to eliminate them? So this is the first thing I'm just going to do. So the easiest way actually we all follow to eliminate things is this one. A square plus b plus 3 and multiply this by a. So why a? Why a? I multiply this thing with a because I'm going to get a term a into b by actually multiplying these two variables and the AB, and then I'm going to subtract the whole thing from this thing, and I'm just going to eliminate them. So how I'm just going to do that? Okay, let me show. So I'm going to get a cube plus AB plus 3, and then subtract or whatever. So okay, plus 8 minus a cube minus ab minus 3a. So now what is happening? They're going to eliminate. Yes, this is what I wanted. I wanted to eliminate ab, and I did that. Okay, so what we get at last? So we have right now minus a cube plus 3b minus 3a plus 8. Okay, so what I'm going to do next? There is another term in there, and that is 3b. So my next target is obviously going to eliminate this 3b again, the same way I did in there. So I'm going to eliminate this one also. So how am I going to eliminate this? Okay, so this is actually easy. A square plus b plus 3, and then multiply this by what? Then multiply this by 3, because 3 times b equals to 3b. Okay, so then what we're going to get from there? So 3a square plus 3b plus 9, and subtract again. Subtract. Okay, so I'm going to subtract this from this term, the things that I left before. Okay, so 3b minus 3a plus 8 minus 3a square minus 3b minus 9. So now what we get from there? So 3, okay, so just then 3b and 3b is out, and then minus 3a, then what? Okay, so 8 then minus 9, this is when we are going to have minus 1. So 3a square and then minus 1. Okay, so just take the minus 1 common, and 3a plus 3a squared plus 1. I am not sure you are familiar with this term or not. I mean, this is actually a very common term. I mean, there's a higher possibility you have always seen this, and you know what is this? This is a plus 1 whole cube. I mean, obviously you know the binomial things, I believe. So if you know the binomial things, I believe this, just seeing this expression, you're going to say that a plus 1 whole cube. This is a plus 1 whole cube. So then what's the next? So after that, we get something like that, and we know, I mean, I can believe that this is, I mean, we are in the right track. How we get that? Okay, so let me actually show the whole question at first. In the question, they say that, okay, a square plus b plus 3 is not divisible by the cube of any prime. Okay, so, and what we get? We get something that is also counted with a cube. That means that we are on the right track. So, okay, I'm just going to write the whole thing again. So what was that? A square plus b, okay, plus 3 divides a plus 1 whole cube. I mean, we just limit the minus 1 thing also. Okay, so this is the first thing. So, okay, so just let me actually show the whole question at first. So in the question, what does it? This term, I mean, this term is not divisible by the cube of any prime. What does that mean? That means that, okay, what does that mean? I'm just going to write the whole thing. What does that mean? That means that a square plus b plus 3 divides a plus 1 whole square, or a plus 1. I mean, you might wonder why this is happening, because this is actually simple. So I'm just going to elaborate this thing, a plus 1 whole square into a plus 1. Okay, they say that the question statement said that this term cannot be divisible by any cube of any prime. Okay, so that means that this thing actually cannot divide the whole thing. Okay, that means that either a square plus b plus 3 divides a plus 1 whole square, or a plus 1. This is this two case, and I'm just going to actually work with these two case right now. Okay, the other one is a square plus b plus 3 divides a plus 1. Now the main thing, the main part. I mean, just look at this one. I mean, like, this is there is a very nice condition in divisibility things that if a divides b, then b is actually greater or equals to a. So this is a very common whatever rules or theorem or whatever that is, or lemma or whatever that is. So then what does that mean? So from that thing we can also write that a plus 1 is greater or equals to a square plus b plus 3. I mean, believe me, just think about it. When is it possible? Like, is it possible? Like, I mean, just look at this one. Okay, so there is a thing when this can be possible. If, I mean, suppose something like b is negative, a negative number. If b is a negative number, then there's a harm. I mean, in the time that a square minus b plus 3. So if b is so high that it actually decreases the whole thing, like it actually decreases. I mean, if b is a negative number, I mean, you can get it. Just think about it. If b is a negative number, then this is possible. And then in no other cases this is possible. So that means that b can be negative, and in the term this is only going to be possible. But in the question, in the statement of the question, they say that b is not negative. So this is not true. This case doesn't work. So the next thing, the same thing is actually works in there equals to a square plus b plus 3. But just look at it. I mean, they're kind of too much similarity. I mean, they're kind of near. Okay, just think about it. If b equals to a, suppose b equals to a, what will happen? If b equals to a, then this term is kind of like a square plus b a plus 3. I mean, just think about it. My thing is, what I want to say is that this term and this term is kind of so near. Okay, they are actually what to say? They are so near. I mean, it looks like that. Okay, so I'm going to just I'm just going to show something in there. And now suppose I'm just going to do one thing in there. What I'm going to do, suppose this is okay, this is like that, 2a plus 1. Okay, this is greater or equals to, what is this going to be? Like, okay, so okay, wait, I'm just going to actually show it. I'm just going to show the whole thing very easily so that you guys can get it. Okay, I'm just making this whole thing so complex, I believe that. So I'm just going to show the whole thing very easily. Let me write the whole thing first. Sorry. A square plus, what was that? A square plus b plus 3. Okay. This is the okay. So okay. Okay, so this is the thing. I'm going to change the color. Yellow is going to be fine, I believe. Okay, how to actually, okay, this color is also going to be nice, I believe. So what's the thing? Okay, now I'm going to do something. Just multiply a square plus b plus 3 times 2. What we are going to get? 2, I mean the 2a square plus 2b plus 3 times 2 is 6. And this term is greater than a square plus 2a plus 1. I mean, just look at it. I mean, what Rachel did, what was the intuition behind the whole thing? The main thing is, whenever we see that the terms, the inequality thing that I wrote in there, I mean, in this position, at first, my best thing, I mean, what I saw in that time, I saw that they're kind of similar terms. I mean, in one side a square, in the other side other a square. I mean, it seems like, it feels like they are so near and things like that. Okay, so I tried to decide how much near they are. Okay, so I multiplied, I mean, what we got in the inequality thing. I mean, according to the inequality is kind of like a plus 1 whole square is greater or equals to a square plus b plus 3. So then what I did, I multiply this whole thing by 2. I mean, what I did in there, I multiplied this whole thing by 2, and what I got a term like 2a square plus 2b plus 3. And this is obviously greater than like 2a square plus 2b plus 3, that is actually greater than a plus 1 whole square. What does that mean? That means that we cannot multiply this by 2. If we multiply this by 2, that means that the inequality is not going to follow. That means that, what does that mean? That means that a square plus b plus 3 equals to a plus 1 whole square. How? Okay, so at first, I'm going to describe why and how again. At first, I saw something like a divisibility criteria in there, and then I tried to divide. I tried to think that, okay, I just created an inequality thing in there, and then I multiplied this by 2, the most nearest number. I mean, after 1, that is 2. Okay, so 1 works in the case of 1, the equality works, but in the case of 2, when we multiply this whole thing by 2, the whole inequality breaks. But what does that mean? We cannot multiply this by 2. That means that only we can multiply this by 1. And that means that this is the thing. Okay, this is the thing, because if you actually multiply this whole thing by 2, I mean this thing by 2, the inequality does not going to work. So that's why these two things are going to be equal. And okay, so what's the next thing? I mean, okay, that's the next thing. I mean, these two things are equal. Oh, nice. Okay. A square plus b plus 3 equals to a square plus, what is going to be? 2a. Sorry, 2a plus 1. What's next? Okay. Just eliminate these things, and what we got at last? We got that b equals to 2a minus, okay, minus 2. Yes, this is minus 2. So, okay, this is what we have just got. Now, what's our next term? What's the thing we should do right now in this point? That's actually very easy. Okay, just put the whole thing, the value of b in this equation. I mean, in this nice equation. Why? Because b, I can just write the b thing in the terms of a. We are going to simplify this more. So what was n actually? N equals to, n was something like, that is in there, okay, ab plus 3b plus 8, then a square plus b plus 2. Then the next thing, just put a, and then b equals to what? 2a minus 2. Okay, okay. My god, my handwriting is just getting worse. 2a minus 2 plus 8. Then divide the whole thing by a square plus 2a, then minus 2 plus 3. Then we are going to simplify the whole thing. Okay, what we are going to get? So in there, a square plus 2a, and then plus 1. Oh my god, sorry. Okay, plus 1. It looks as t, it's not a plus sign. Okay, so, and the term, okay, so it's like 2a square and 2a. Okay, so 2a square, then 2a, and 3a, 3, 6. So subtract 2, then I'm going to get 4a and 2a. Okay, so 2 times 2, 6 plus 8. Yes, so that's 2 plus 2. Okay, then, okay, oh, this is just 2 times the whole thing, that is just 2 times a square plus 2a plus 1. Okay. So what's the answer? N equals to 2. Okay. So this is the thing, and okay, so what AB actually works for the whole thing, and that is A, and then 2A minus 2. Okay, so let me review the whole thing from the beginning and what we actually did in the here. So the first thing first, I mean at first this whole divisibility things and getting this, I mean they are quite, I mean straightforward. So actually I didn't pay enough attention in there. So that was the whole thing. Then the main thing is this one. I mean, okay, this thing, and this thing. I mean, this is a term when the things are going to divide into section, and then actually we did the inequality things, and inequality thing shows that this is not going to work, and on the other hand this is going to work, and then okay, again just we then try to show that if we multiply this thing by 2, then things are going to get messy on the other hand. So that means that what? That means that okay, then we get this thing also from there. Okay, I mean if we multiply this by 2, the inequality is going to break, so that means they're equal, and only if they're equal then the inequality is not going to break. Then from the equality case we get this beautiful and nice thing, and then we plug it and we solved it and we are done. So this was the whole problem, the things and everything. I mean, I just love this. I love this thing. I love the whole problem. So what we have just learned from this whole problem, I mean, just think about it. I mean, what I learned from this problem is whenever you see something divisibility criteria, then you get something like that divisibility things are so nearer, then your task is going to face or just try to think how much nearer they are. Okay, so we try to think how much nearer they are, and we multiply that time by 2. Okay, so in your term you can multiply these 2, 3 or 4, then try to decide, I mean, how much nearer they are. Okay, and when you get that, then we can easily use that equality things. Okay, so I mean this equality things. So in this whole thing the problem is nice. So that was the problem. Yes, we have just solved, and I'm a shortlist. Congratulations to all. Bye bye.